Good afternoon, Mads. Oh my gosh, thanks so much for joining me here today. We've
Well,
had a
thanks for having me.
we've had a long day getting started, showing folks a bunch of the stuff that's been happening with C Sharp and showing them some of the basics. Can you give folks a quick introduction of who you are before we get into this?
Sure. Yeah, as you said, I'm Mads Torgersen. I've worked for Microsoft for nearly 13 years now, and I'm um, I'm such a rare thing as a professional language designer. So I'm actually I'm the dude in charge of making sure that new versions of C Sharp come out all the time. So when you've seen today structured as C Sharp 4, C Sharp 5, C Sharp 6, or whatever. I think you've had it pretty much like that.
Yeah, just covering a little bit of features as we went along. Yeah,
Uh, those numbers are like I'm the one who keeps pumping out new ones.
you're the one who's moving it along.
Yes, exactly.
All right, and I've got
So,
folks in the chat room commenting on your whiteboard.
oh, I guess I didn't wipe it completely.
Ah, that's funny. All right, so
Okay.
so I know there's a
So,
lot of new things happening with the language this year. And we've seen right with C Sharp 7, there's a bunch of new stuff that you've introduced. Um,
yeah, it's been a busy year. Uh, about a year ago, a little longer, we had our latest major version of C Sharp 7.
okay.
And that's mostly what I'm going to talk about today. I hope somebody else hasn't covered it.
Nope. Nope.
Um, then it'll be a long hour. But since then, we did something that we haven't really done before, maybe all the way back in the version 1 times. But we shipped some what we call point releases. So 7.1, 7.2, and 7.3 of C Sharp in rapid succession. And it was only partly because we forgot to put some things in. It, it was also in recognition of certain scenarios that we wanted to help out with that that were coming online at the same time. Some people may have heard of span of T, for instance, which is I'm not going to show today. It's sort of a little on the expert side, but which was a thing that we wanted to align with. So we put out some versions of the language that were focused on that, but also just the fact that we can now more easily with VS updating so frequently, we can more easily push out new versions. And we wanted to experiment with that and getting the value that we already built to customers faster.
Very cool. All right. Why don't I go over to the code and you can start showing us some of this stuff
Yeah.
that we've introduced and we've enhanced here. All right. So I'm going to switch scenes. There we go. All right.
Ah, that looks just like my screen, except with the colors inverted.
Yeah, we had a nice discussion about colors yesterday. How I like the dark theme, and Mads likes the
Yes.
light theme.
Yeah, that's and so we clash all the time, but we bring balance to the force.
So we're using live share here, and you can see where Mads is there on line 12 of my screen. All right. So what do you want to touch on first here? I could see this looks like a simple console application.
Yeah, I've done very little here, except I always like maybe Bill showed this. I think he was the C Sharp 6 guy
Yeah.
using static. So I use that a lot. So I don't like saying console or write line when I can say just write line. So
Oh yeah.
that's the only thing I really did in here. And then we're going to start from scratch with this happens to be a .NET Core console app with C Sharp. So maybe as an introduction, I should say that if we haven't had enough of those already, I should say that when we evolve C Sharp, we try very hard to make the new features feel as much as we can as if they had always been part of the language.
Mm.
All right? So we try to make new features that blend in and that are useful, but don't sort of upset the feel of the language too much or feel like they're glommed on or stick out. So
Sure.
I'll try to sort of point to some of that along the way here. Maybe at the end we can talk a little bit about also at least one of the features that we're thinking about for the next version of C Sharp. I can show a little of that. And this is
Okay.
actually I have a prototype running here. This is actually not the VS that you have, but where I can show some of that if we get there.
Okay, so that's kind of impressive also about live share here is you're running a prototype and I'm here in a preview, a public preview, and I'm not impacted by some of those preview bits, some of those prototype bits. But I get to see the results of them.
Exactly. The language service that I'm running is the one that you're running that's showing results on your screen as well. So it's pretty impressive.
Yeah. All right.
But okay, let's get started. So let's start easy. So I don't know if you touched on it, but I'm going to create just an array of numbers, an int array of numbers, and I can do that like this, and then put some comma-separated numbers in here. And I want all the powers of 2. And one of the things, because ints are also being used for bit fiddling, so one of the things that's been in the language forever and that we inherited from sort of the C heritage, if you will, is that you can write your numbers in hex. Right, so always in C# you were able to say 0x1, and that means 1 in the hexadecimal base, number base, if you will.
Here, let me put a comma in there for you while you're typing.
Oh, you can do that. Yeah, thank you. Yeah, you can just come after me and clean up. Thank you.
I got to help write C# with Mads. I feel amazing now.
Can you do this all day, please? So we can keep going here, but nowadays, isn't it a little like so 90s or 70s or 60s to have to remember hex numbers? And so if you're really out to express bit patterns, you should use binary. And so we added the ability that you can use binary instead. So I can write 8 like this and 16 like this if I got my counting right, with a 0b instead. This is really a tiny feature just sort of to get us going.
But it's removing some of that friction. It's making me. It's one of those things I don't have to think about the powers. It's just, all right, keep moving the bit over. I'll just add another 0 on the end.
Yeah.
Oh.
But now it's kind of getting hard. I'm getting to counting here. I think I got that right. But the way to tell is that we also now have digit separators in C#. You can put little underscores wherever you like in your numbers. And so it's easier for binaries. They get long quickly. That's a good thing to be doing.
So that underscore isn't actually interpreted by C#. It's just a marker there for humans to understand.
Yes, it's allowed to be there. It's called a digit separator, so it has to be between digits or right after the base specifier if you have one. So
okay.
And I can put they don't have any effect. Like the compiler throws them away. But if they make your numbers more readable, then as they did here, I think, and that's a nice little touch.
Little cuts, simplifying things. Oh my gosh, yes.
So we always try to do some of this where we just let's make the easy stuff a little easier, and let's just keep trimming the hedges, so to speak, and then also do some big stuff. And so let's get to some of the big stuff.
Okay.
And so the first feature I'm going to talk about is tuples. So let's call a method with these numbers. Did you hear about var already?
We did. We talked about var and how it does that duck typing. It sees, oh, that's this type, so I'm just going to make it that type.
Right. So I love var. It's a wonderful thing. It infers the type from what comes back from the right-hand side here, but nothing comes back because I don't have a tally method yet. So what I want to do is write a little method, call it tally. So let's have it generated here that takes these numbers and adds them up, but also counts them. So I want to both know how many there were and what the sum was.
Now, you used a refactoring in Visual Studio to generate that method signature for us.
Yeah, you probably didn't see see all the menu stuff that happened, but the code just came in.
Yeah, it's just amazing.
Mm-hmm.
Mads types just that fast.
Yeah, I like that. I like the combination of refactorings and live share here. It makes me look really impressive. So it just kind of generated whatever method signature it sort of guessed that I might be interested in, but it doesn't know what I'm intending to return. And really, I'm intending to return two things here. But in C#, up until recently, you can only return one thing. Like in many languages, especially C-style languages or the curly brace languages that C# is sort of derived from. So you could return one of them, but then which one don't you want to return? You have two results here. You can
Okay.
have as many parameters as you like. So I could add more parameters here, but you can only have one result. And that's an asymmetry in the language that we wanted to fix, but we wanted to do it as symmetrically as possible so that it feels like this is something you could always have done. And so what we let you do is to say that instead of returning one of them, I'm returning two ints, and it kind of looks like a parameter list. I have two types here, two int types.
Yeah, it
So
does.
and what I actually have here is actually a type in and of itself. So there's still really only one return type, but it's a type expression that looks like a list of more things because it is. This is a tuple type. You can have them as big as you want, and with any non-pointer types in there as you prefer. So you can return now as many things as you want.
So there's a quick question in the chat room. Exactly which version of C# are we using right now?
So now I'm in C# 7.0, or I'm using features from there. I'm actually a little further ahead, so I'm in C# 7.3, and we'll see a few features maybe from there if we get to it.
Okay.
But yes, this is a C# 7.0 feature. And now we can see that the thing that comes back from my tally now is a tuple of two ints. And now it gets interesting. Like,
so if I mouse up here, right, I see I can see on my screen, right, IntelliSense is telling me it's a local variable int, comma int that it's returning.
Yes. So now I want to write something useful out from that. I got two ints. How can I get at them? So let's try to get the sum using interpolated strings here. Then what can I do with my t here, my tuple? Well, it looks like it has an item 1 and an item 2. So this is sort of like apparently it has, properties or fields that represent each of the int elements that were in there. So I pick item 1. We say that the first one is the sum, but and that works. Right now I can write it out, but it's a little unsatisfactory that I kind of have to keep track of or look at a comment to see which of the ints is which.
It's not descriptive as to what it is. It's just positionally the first one.
Right. So it has too much of an emphasis on just the position, and there's too much sort of implied here that's not supported by code. So we added the feature that you can optionally name your tuple elements, the sum and the count here. So now when I hover on the result here, you can see that those two elements now have names, sum and count. You hovering there as well?
Yep.
Good job. And now, you even get the little dots here on the t.item1.
Oh yeah.
They tell me that there's something I can do better, and if I go back and press dot, you won't see my completion list. Can you press dot there? Do you see the completion list?
I can. Oops, wait a sec. My cursor's in the wrong place. Hang on, let me put the cursor down there, and I'll dot into it. There we go. Now I see sum and count in the completion list.
Sum and count are there instead of the generic names, so to speak. So now you can select sum there, and we're really pair programming. So the old names were still allowed, like the generic ones, but they're not offered and they're not recommended. It's much better to use the actual name that was provided.
So let me ask a couple questions that we have coming in from the chat room about the tuples. Are they returned by value or by reference? Cryptrix asks.
Yes. So what do you actually get back? So a tuple is actually a value type. It's a struct, if you will.
Okay.
So it's copied back, and that sort of, again, part of the reason for that. There are several reasons we chose that, but part of the reason is, again, the symmetry with the parameter list. When you have a parameter list, you don't build like an array or something or structure and then pass in a reference to it to the method with all the parameters in. All the parameters are copied individually. And the same is true so we want the same to be true when things come back. And the way we achieve that is to put them in a value type that gets copied back by value.
And then the second question was, why not return just an object or a dynamic from this?
So people used to have all kinds of other ways of doing this. If you do that, then if you return a dynamic, for instance, then you could do the same thing. You could dot in and say sum, but you could also dot in and say anything else. And then when you run your code, it will blow up. When you have dynamic, you don't have any any static typing. You don't have any type safety. You don't know what you're getting.
The compiler is helping you in checking on some of those things.
Yes. Yes.
Awesome.
So this kind of lets you have that strongly typed return without having to declare some carrier type yourself, like declaring a little class or struct for all the values you want to return, which makes your code incredibly noisy. Okay.
Yeah. All right. Now, MSA Pygen, I hope I'm pronouncing that correctly, or is that, I'm not sure, but says, can you name a good example of when to use tuples? Well, I think this is a good example that Mads is showing here. I'll let you finish.
Well, so yes, so the definitely the driving example, the one that we really wanted to nail was returning multiple things.
Yeah.
But tuples they're a pretty decent type in and of themselves. They have value equality, for instance, so that the way that you determine if two tuples are equal is to compare the elements pairwise, right? So, and they have a good associated hash code and so on. So, for instance, if let's say you want to have a dictionary that has multiple keys, right, where all the keys have to be right in order to get the element, you just use a tuple type as the key, and it has that effect, because then when people come with a key and say, can you look this up and see if it's in a dictionary with multiple values, then we get the right hash code and we look up in the right place and get the right equality, and all things just work out. So it's good. It composes well with other types. I can mention now, you probably heard a little bit about async in an earlier.
Bill didn't want to touch on async. It was a little bit further advanced, but we have talked about async previously on the stream.
So I will just briefly touch on it then and say, let's say you have an async method, what you always return from an async method is a task of something. That's kind of like you give something back that's a promise to return something later. I'm not actually using task right now. Let's just do that quickly so we don't get the red. And what this shows is that even though it sort of breaks the illusion a little bit that this is multiple returns, because you take them all and you wrap them in one like wrapper object that will return the result later when the async completes. But it's actually great, right? Because the composition of the single tuple type with other things we do with return values works out. So tuples and other types compose well. You can have arrays of tuples and all that, whatever you want. So so that was just, I'll get out of the async mode here again, but that was sort of just to point that out. Okay, so let's implement this method in a slightly more useful way than what's here. Like we can create tuple values by using a tuple literal syntax essentially, right? So I can return 0, 0 here, which is not a very useful result, but it's it just shows that they're tuple expressions.
Okay.
And if we go ahead and I'm going to use the refactoring. Actually, do you have? Let's see. Could you bring up refactorings in that tuple literal there?
Sure. Let me highlight. And
let's see if we have it in
control dot. Introduce a local extract method.
That. Introduce a local.
All right. There we go.
Now, yep. Now we get a local for it. Now we can start implementing the method for real. So you see that we're creating a tuple. You can actually give names to the tuple elements in a tuple literal as well. I could call them even something different. The compiler doesn't really complain about the names not matching up. The names are not there to prevent you from doing things. They're not part of sort of the enforcement of the type system. They're just there to be helpful.
Okay.
So if you want to call them something different here, that's fine. As long as the types match up when I return it here, the types in there match up with the return type.
Discordia asks an interesting question. Well, is making a point here that using tuples as dictionary keys, that feels peculiar to me.
Okay.
Right? I mean, you'd have several different values as a key into a dictionary through a value tuple, right? That feels.
Let's say you have some data series from a survey. You want to order them by gender and age, right? You want all the 27-year-old males in one bucket and so on. Then maybe you stick them in a dictionary. That might not be how you do it in reality. I'm just making up an example here.
Sure.
That's keyed off of both age and
gender. Yeah.
gender. So it's just for that kind of thing.
Okay.
To be honest, I haven't seen like super many uses of this. It just comes up here and there. It's just one of those tools in your toolbox. But the vast majority of uses of tuples I've seen since we introduced this and that I've done myself are related to results out of methods.
Okay.
But the other scenarios are, I mean, we designed for them and they work well. It's just, you reach for that tool whenever you want to sort of accidentally and temporarily group some things together. They don't have a close relationship to each other. The grouping doesn't have like conceptual value. It's just like, hey, I need three things. I need these three things, and I don't have to create a special type to hold them.
Okay.
I can just group them together, and the language helps me all the way.
Okay, makes sense.
Yeah. Now we can implement this method for reals. Let's reach over those. Actually, let me rename numbers to values before I get too far here, because I'm going to go crazy in a bit and not just have numbers. So now you know. For each var
spoiler alert,
v in values, say. Yeah, I also watched Solo already, and I can tell you everything that happens.
You did not.
No, I didn't.
I was going to say jealous.
No, I didn't. So if we reach over them, how do we, now we can use this P here. Let's call it instead, let's call it R for result. Renaming it there.
Oh yeah, we saw a flip on line 23 also.
Yeah, right. Doing some of my secret refactoring magic over here. So what we can simply do is we can say we can update R to be a new tuple that's produced from the old tuples S plus the new value, and the old tuples C for count plus 1, right? And we just go around in a loop and do that and return the tuple that results from that. So simple way of tallying.
Okay.
One thing that you may like or not like, and if you don't like it, you can just not use it, but tuples are actually, they're value types, right? But they're mutable. You can change them, the tuple value itself. And actually, these elements are fields, public fields that you're assigning directly into. There are no properties in the tuple. It's all fields, public fields. So that's something everybody who's like building abstractions and doing encapsulation and so on with object-oriented programming, they go, oh no, you are like breaking all the rules. And yeah, we know, but this is not actually supposed to be an encapsulation and abstraction. It's supposed to just, again, be the individual variables sort of just bunched together. So that's how we did that. So based on that, instead of mutating all of R, I can go and mutate the individual elements of R. So I can say R dot S plus equals the value, and I can say R dot C plus plus actually. And you can probably get a joke out of the fact that I wrote C++. That also works, right? I'm just mutating the tuple in place.
Sure. All right, that makes sense.
But even if you go back to the other version there, even when I'm doing it this way, I'm not, because they're value types, I'm not sort of like people who are worried about garbage collection and allocating new objects and so on. I'm not actually doing that because they're structs. They're allocated in place on the stack here. They're not churning memory, if you will. So
gotcha.
Creating a new one every time around is not expensive. Okay, so I think that says most of what there is to say about tuples themselves.
Yeah.
But we say a little bit more about the consumption of them, which is sort of a special case of another feature we added, that sort of a companion feature. It's called deconstruction.
Yeah, Brendan in the chat room was mentioning that deconstruction is much more awesome. Yes.
Okay, so he's been wanting to get to that. Okay, well, now's the time, Brendan. We're going there. So the fact that two values come back here, I said we kind of want to blend it into the background that there's actually even a tuple there, right? It's just sort of like a circumstance, an implementation detail, if you will. So it's annoying that we have to kind of give it a name and do things to it. What if we could just take those two values and immediately put them into each their own local variable here. Instead of one local variable, we could declare two. And you can do that with deconstruction. So we can say var, again, S for sum and var C for count, and put that on the left side of a declaration here. And we're now declaring two local variables. And the fact that they're in parentheses like that means deconstruct the corresponding tuple that comes back here into its constituent parts and put each of those into their own local variable.
Break it down. I know there's two parts here. Put the first position in the first one position I have here, the second in the second position. Makes sense.
Yes, exactly. Yeah. So, and once you do that, let's give them slightly more useful names on this side here. Once you do that, then you can see the T is no longer there, but now I can just use sum directly. I just got a name for that value itself. And the fact that there was ever a tuple value is completely, it's completely gone from the source code itself. You're just thinking about the individual values and passing those along. What you might notice here is that I'm only using the sum, I'm not using the count. So we also have this notion of a discard. That if you put an underscore, then it'll ignore that thing. You don't have to give it a name. Now it's just throwing the count away. So that's deconstruction. You can do it with tuples. You can also do it with your own types if you give them you have to give them a method called deconstruct with an out parameter for each value you want to deconstruct into. It can be an instance method, or you can add it as an extension method. And then the compiler will see that and say, hey, I'm happy to take whatever it is you return that has that ability to deconstruct, and I'll call that, and I'll also let you put it into separate variables. So if you have like some data class, point, or something that you want to just dissolve into its components in situations like this, an assignment essentially, then you can add that capability and the compiler picks up on it.
Now, Jay Rosegard in the chat room is saying you can move the var actually outside the parentheses there on line 11.
Yeah, that's a good point. Let's say we're still back and want them both. Saying var a lot of times here, it's still, I mean, this is neat and compact and everything, but you can actually make it even a little more compact by saying var once outside. Right? So if they were all vars, or even in their mix of vars and discards, you could just put a single var on the outside.
Yeah, that's nice.
Yeah. Now it's like, it's pretty slick now. Yeah. I like it this way. Some people like it more explicit, and we kind of just give you the range of options there.
Now, are tuples matched by structural equivalence? I thought they were just matched by position, to answer the question in the chat room, right?
In this case here, this is by position. When they say matched, do you mean like
when we deconstruct and bring it out here?
Yeah, it is by position.
It's just by position.
But that sort of is structural, if you will.
Yeah.
I guess one thing that you could say is structural is that, let's say you have a tuple with tuples in it. You can deconstruct recursively if you really want to, right? Let's say that there was a string that was coming back here as well, string name or whatever, is coming back from the method. I can ignore the whole tuple, or I can grab that tuple into a T, or I can recursively deconstruct it into a C and an N here, for instance, for count and name. And now I have three local variables, sum and C and N, that are sort of matching the structure of the tuple that's coming out. And it's all statically checked, right? It's all based on the return type here coming out. Oh, yeah, you can see me highlight, coming out of the method here and matching the structure of the deconstruction here. So yeah, you can do crazy things if you want to, and it is sort of like structural, and recursive.
Now I've got to ask, and it's just that Q&A mindset. How far can you nest down tuples?
As far as you like.
Okay. Be as crazy as you'd like.
Look, we're in the business of generality when we create a compiler. So not only can you nest tuples as deeply as you like, you can make them as long as you like. There's I mean, there are underlying struct types that are defined in the BCL, in the base class libraries, but so there's only like a certain number of those. But if you go beyond, we start nesting them secretly. We have like the compiler generates actually a nested tuple for you, even for a flat long one that's bigger than the types that can hold it. And we'll nest as far as it goes. If you want a tuple with 93 elements, we got you covered. So passing that by value is probably bad. Like you're copying a very large tuple around all the time because it is a value type. But hey, you can pass it by reference. That's supported in the language too.
So Discordia is making your point very nicely here, of putting that together and saying the compiler can handle more tuples than your brain can handle.
Mm-hmm. We just got to stay one step ahead of your brain.
Well played there, Discordia. All right.
Yeah. So actually, what happens is that whenever somebody uses a larger tuple than we accounted for, Visual Studio calls us up, and we have a developer really quickly code that one up and send out a patch. That's how it works.
Let me ask final question here before we move on to your next topic. Can tuple members be references?
They can be reference types.
Yeah.
They can't be ref. Like if you think about refs to structs and that you can do on parameters, like you can have a ref parameter. They can't be that, but you can. The things inside of tuples can be any type you like, as long as they're not pointers, which are unsafe and which we probably don't talk about today.
Yeah.
So any type you like. It can be object, string, your own classes, structs. No limitations there.
Very cool. Did the value tuples replace some other feature, and were there performance improvements because of this?
Yeah, there's a system.tuple, which is a class, a reference type that has been sitting in the framework for ages, and we decided, and that's also immutable. And we decided not to use that, partly because of the name thing, with allowing the names on the tuples, but mostly because we wanted to have this pass by value, this copy by value semantics. We also liked the mutability that we could get with tuples, or with the struct-based tuples, but the main reason was have similar characteristics to parameter lists as much as possible. That makes them predictable. That makes things symmetric around method calls and returns and so on.
Very cool. All right.
So, ready to go crazy?
Let's go crazy.
Let's go crazy. Yeah. So, let's say that that we don't have a nice array of numbers, but we have crazy things. It's actually not an int array, but you get like dirty data. Some of them might be ints, but you might also have some nested arrays, maybe. Maybe some of these are in a nested array. Let's call it new object array, where there's a couple of them are nested. Maybe there's a null in here somewhere. Because the data is kind of dirty.
Yeah.
You see the warning on the null there?
Oh yeah.
That's my prototype language service that's actually kicking in here. We'll get back to that. We don't like nulls, but we're thinking about how to handle them. So when we talk about the next version of C#, we'll come back to that warning. You won't get that if you write this code in Visual Studio. It's my warning, not yours. So
we won't get it yet.
Yet, exactly. So let's say there's also maybe a number in here that's actually in a string, or in a string literal, and so on.
Okay.
So they're all sort of numbers. There's some numbers, and we can still talk about adding them up and counting them, but they are weird now. And we kind of have to do some data cleanup. Okay, so I now have to change my parameter type here to take an object array, and now I have this weirdness of how do I deal with that, all those different kinds. Like I kind of sort of want to do something per different type that I can encounter in this array of objects. Before I do that, I want to sidetrack really quickly to another language feature we added, which is going to come in helpful here, which is local functions. Like we looked at defining methods at the top level, like main here, and tally here. They're methods that sit inside of a class or interface or struct. But sometimes you just want a little helper method, and sometimes it makes sense to write it actually inside of your other method, right? So let's take this functionality of incrementing the result tuple here, and let's actually abstract it out, because I'm anticipating now that I will need to do that from multiple different places in my code in the different places that I clean something up into a number. So let's make this a method that takes takes an int sum and an int count here and does something. And what we want to add is the s to the sum and the c to the count. Okay.
All right.
And I need to give it a return type here, otherwise it gets confused. There we go. What are we?
Should that be an expression value, right, with the fat arrow instead of equals?
Oh, you're right. Yeah, you're right. Yeah. Of course, I should either have curlies or an arrow. There we go. Yeah, I don't know C# very well, but I get by. So so now I have a function. It could also have curly braces around the body here. So just like another method, but it's nested. So it's local to the method.
Right.
And you can see the fact that it's local is really useful because it lets me use the R that's declared outside here. On the other hand, it doesn't use the V, so I can take it and move it outside of the curly braces, and I can actually even move it to the end of the method because they can, unlike local variables, local functions can be declared after their first use or used before their declaration. So sometimes you want to structure your code. People know this pattern from JavaScript and other languages that have nested functions. Maybe that you can. It's very nice that you can sort of have the general logic specified first in terms of some helper methods that are then detailed at the end. So that's what. So coming back to our code from before, we were adding v and 1 and using that local function. But of course, we can't just add v anymore. So coming back to our problem with now having an array of objects, we can't just add v anymore because we don't know it to be an int yet. We kind of have to check. So we could say if v is an int, then add v as an int or something like that. That's what we would say pre-C#7. But C#7 adds a pattern matching, which is a new feature that we're adding in C#7 and then expanding upon in future releases. Okay. So we're adding this new concept of a pattern, which is a pattern is essentially, so let me use it first and we can talk about it. So I'm actually adding a variable name here now to the is expression. What I'm saying is that if v is an int, then call that int I and use it here. Okay. So the is expression is now not only checking the type, but in the case where it has the type, it also gives you a fresh variable with the value in at that type. And that's actually pattern matching. And the thing that's the pattern is this part here, the int I. That's an example of a type pattern. A pattern is generally something that can be fulfilled or not. It's like a test check.
Okay.
When it's fulfilled, it can also extract information from the thing that it's testing. All right. So an expression is coming in, the v here, and the test that's applied for this particular kind of pattern is it an int? And if that happens to be the case, then call that int I. And because in the true branch here we knew it to be true, then we know it to be an int, and we can use the I without any complaints. Okay, we know it's assigned with the value of the v.
All right. Now, Shane's commenting that your single character variable names would fail code reviews. That's okay. We're just trying to write some code quickly here.
I mean, people have to understand. I'm not a developer. I don't have manners. I'm just a language designer, so I can do these things.
And another comment here is, I prefer emojis for variable names. I think that's a bad idea. That's just right out. We don't want emojis for variable names.
Well, I'll say this for it. There's only so many emojis you can tell apart. So it keeps your code simple and clean, I guess. But each to their own.
Yes. Okay.
Now, if I were to, like, that was one case of what V could be, and I could sort of say else if and else if and else if all the way down. But I'd always be testing V, right? And so this feels more like a switch kind of situation. And indeed, we can also now use patterns in switches. So let me go do that instead. So I say switch on V. And there used to be all kinds of restrictions with switch. There's no point in me telling you what they were, but you can switch on any old expression now. And then one of the cases in your switch can now be a pattern. Case int I, and now I can say what? So it's same as before. This is a pattern. If I fall into this case, I knew there was an int, and I'm calling it I, and I'm using it here. So now I can say add I comma 1 for this case here, and we can similarly, what else do we have? If it's let's say it's a nested array, case object array, I can give that a name. Let's call it A, just to keep ticking off that person who doesn't like the single variable names.
There you go, Shane.
Names. There you go, Shane. Actually, I have to break. This is one of the nasty things about switches can be a little verbose. We're also looking to address that in C#8, but I'm not getting into that here. So I have an object array. What should I do with it? Well, why don't I call tally recursively with it? So I'm going to tally that array. I'm going to get some. I'm going to get a sum and account of the subarray back. So I'm going to call them S and C here in a deconstruction. So it's all coming together. Then I'm going to add those S and C, and then I'm going to break. So I'm kind of doing this recursively. Now,
let me scroll down a little here so we can see.
So you see, this is actually not, if you watch Bill talk about exception handling earlier, this is not too different from having catch clauses that catch different types of exceptions. And he was talking about exception filters. I know, because I was kind of sneaking in at that point and looking how everything was going. You can, similarly to exceptions, you can also put filters on here, when clauses. So we can say we actually only want to do this. We don't bother except when the length of the array is bigger than 0. Because otherwise, why go and call recursively on an empty array and add 0, 0?
And
so,
can we just back up a second? There's a question in the chat room asking for a little bit more explanation on the case int I.
Yeah.
So that's a pattern that we're matching. It's looking at, instead of switching and saying, well, does V, is it this value, right? Which we've seen before you can do with switch. We're actually testing, does it match this pattern? Is it an integer? And if it is, shove it into the integer value called I.
Yes, and then run the body of the case. Exactly.
There you
go.
So
it's applying more complex things to the value than just constant comparisons.
Cool.
And actually, one of the kinds of patterns we have is a constant pattern. Let's go use it. So I can still say case null, colon, but we're sort of reinterpreting that to, and actually I probably don't want to do anything if I see a null. I don't even want to count it. That's a constant, like you've known from switch all along. We're sort of now reinterpreting that to be a constant pattern, which you can also use in an is expression. You can actually say V, if V is null, null is then a constant pattern. Yeah. So that's kind of like a good way of checking for null. It's better than using the double equals, because somebody might have overridden that to mean something else. If you want to actually check that a reference is not null, use the is expression with the constant null pattern. But I'm using it here in a switch, so you can still do that and mix and match the different kinds of patterns.
So how is that better to use is null versus just equals null? Is there a performance difference? Is there...
There might be a little performance difference. Well, let's put it this way. If somebody overloaded the equals operator on the type that you were looking at, then they made that mean something else. So calling that something else is likely to be less efficient than just a regular reference comparison. But moreover, it's probably also doing the wrong thing. So...
Oops.
So if you're checking for null, you typically don't want to call user code. you typically just want the compiler to check that it really isn't a null reference.
Okay.
And that's what you get when you use the is way of changing. So I've changed all my null checks to be is instead of equals in my
Okay.
that's how I do it now.
Then it reads more like VB.
Yes. But only a little. So so you can also, let's just deal with the array when it's actually length 0. So case int array and point. And I can actually, again, I can use the underscore if I don't actually care about it in that case. And we see here that cases are now handled in order, just like exception handling, just like catch clauses. So
Sure.
We will only get here. I don't have to check that the length is null. I will only get here. Oh, it should be object array. Sorry. I'll only get here if the previous case didn't satisfy its additional when clause here, and so.
Okay. And by using the underscore on 30, you're saying discard this. I don't want to do anything with it.
Yeah, I'm saying if you're an object array, and we got here, then you are empty, and I don't care about you. So I'm going to fall through. Because we still have fall through in switch statements. I'm going to fall through to do the same thing as I do with a null, which is nothing.
Cool.
I'm going to do that.
Right. The 30 and 31 lines there are effectively doing an or, right? If it's an object or if it's null, then break.
And so actually, because there's an or between them, if I had given it a name here, then I wouldn't be able to use it in the body because I could have come in through the other case, which didn't give a name. So you can't. So if you want to capture things into variables, you can't do that with. You can't also do fall through.
Okay.
Then you don't get the ability to use it in the case clause. So one last thing I want to show here, and then we can talk a little bit about the future. Is the case where I gave it a string literal up in the array here, which I can see just on your screen. What do we want to do about that? Well, we can say case, let's just put it at the end here, case string s when. Well, we want to parse it as an int. So let's say int.tryParse. Have you seen try methods today?
We didn't spend any time with them, no.
Okay. So there's a whole pattern that you'll see around the .NET frameworks and dictionaries has a try get and so on. The try pattern means I have a method that returns Boolean if the operation was true, to tell whether the operation succeeded, rather. And then any additional results are returned as out parameters on the method. So into TryParse, I want to try parsing the string s and into an int. And if I succeed, I want to put it into an existing variable. Or prior to C# 7.0, you would have to pass a variable here that you already declared somewhere.
Right.
But the somewhere that I could declare another variable is, it's terribly far away. It's all the way out, outside of the switch, all the way out. Can you see me up there now? All the way out there, which is kind of like nasty to declare a variable out there just so I can use it in a particular case down here. So now we'll let you declare variables directly in the out parameter by saying, for instance, int I here. Or I can just say var, because I know I'm passing it to something that takes an out parameter that's an int. So that's what we call outvars, and that's sort of the last feature I want to show in C# 7.0, that you can now declare variables in it. That's actually a bunch of new places now that you can declare variables. That was inside of the deconstructions. We have one here, which is sort of multiple local variables rolled into one declaration. There was inside of the patterns, like the I here or the S down here. And then there's inside of outvars, you can also declare variables there. So a bunch of new places where you can declare variables.
Let me scroll down just a smidge here. There was a question earlier about how you used R down there in the add method in 39, line 39. That's actually a reference to the same R that's declared on 18. Mads didn't actually create a new variable. He's saying, this is the body. Reset R to be this new value, and the R is that R that's declared up on line 18.
Yes. So the fact that I'm inside of the method that has R declared all the way up there on 18 is the R is in scope for the whole tally method including for the add method down here.
Right.
So let's see what I'm doing wrong here. Case string R. Control cannot fall out of switch from final case label. What? Oh, you're not seeing an error.
Nope, not seeing an error. Everything looks good over here.
Okay. I think that's my prototype acting up actually here. So don't you worry about that then.
I won't.
I have a sea of red over here, but that's apparently only for me.
All right.
So so that's a bunch of like features that help you pass data around, in particular back more easily, help you do various kind of matching operations on values to kind of break down into the different kinds of shapes it might have through the patterns. So that's a lot of what's in C#7. So maybe we spent the last 5 minutes or so looking at one of the things that's coming up. Would that be good?
Sure. Let me just, there's a nice compliment for you here in the chat room from Cryptrix. He says, during the 90s, I remember many people did not like syntactic sugar language features, but these changes in C# make for it significantly easier to read and comprehend the program. These are great features.
Oh, thank you. And so just a quick comment on the notion of syntactic sugar. Syntactic sugar is often used for something that's just an abbreviation of something else.
Yeah.
And to be clear, we often do that. Like we like that. We like doing that too. If it's something that's common and that reduces complexity of what you're looking at, then we'll take something that you could perfectly well have said before, and we'll create syntactic sugar for it. And the compiler will just like rewrite it to what it was before, what you would have had to say before. And it's really just, in a sense, it's complicating the language for no good reason from an expressive point of view, but from a productivity point of view and a readability point of view, it helps. In this case, though, I will say that if you, for instance, look at if you look at tuples, you look at pattern matching, you look at deconstruction, they're closer to being, they're conceptually deeper than just sugar. They're close to being like, they're more like real semantic features. It doesn't mean we still rewrite them to the same target language, which is the CLR's IL bytecode language. But the rewrite is not trivial anymore. We're actually really adding new semantics to what you do. Does that make sense?
It does. There's one more question here that I think your terrific insight you're going to have on this question is, do you have any good reads for people who are interested in language design?
Good reads. Ooh. I don't know any books about it.
Okay.
But some people blog about it. Back when Eric Lippert was on our team, he blogged about some of the design conundrums involved in designing C#. I think he still blogs about language design some, except different language, but there's still good insights. If you're like really into language design, you can actually go to our GitHub site for language design. Like Sarah was just in here talking about Git and GitHub, and we have a GitHub site that's github.net/c#lang.
Yeah, let me flip over there. We have it in our list of resources today.
Yes.
So if I scroll down here, so here's the C# workshop README. If I scroll down here, so Mads wanted me to make sure that I linked to our C# language wiki, and
right.
That'll
so that's if you want to play with the new prototypes. But if you want to see the sausage getting made, this is our public repo where we keep all our in-flight things. So you can go and look at, if you look at meetings there, the code inside of this repo is documents. It's write-ups, many of them being like drafts that I never cleaned up or whatever. It's whatever I got typed down when we did our design meetings, which we do up to 2 times a week, me and a bunch of great people here at Microsoft. And you can sort of see the design sausage getting made by looking at all the discussions we have, all the dead ends that we take, and you can see us being all, yeah, we figured it out about something, and then a week later we're like, nah, that wasn't right after all. So that's if you're interested specifically in C# language design, this is the repo to Rome.
Very cool.
And in there, where the link takes you, is the wiki, which is the prototype I'm about to show, and also another prototype are currently publicly available. You can install. There's an install script. You can install and uninstall them and try them out.
All right, let's quick show that prototype. Oh gosh.
If you want to try some of the features that we're working on for the next version of C#, and give us feedback. So there's all instructions in there. But so just to do it in a 2-minute version of what we call nullable reference types. So you saw the squiggle. If you scroll up to the top here, you saw the squiggle on the null here. And what happens if you hover over it? Does it actually tell you?
There we go. Cannot convert null literal to non-nullable reference or unconstrained type parameter.
Right. So one of the big problems in almost all object-oriented programming languages and a good deal of other languages is null. Like we allow the null value into our types, but then we walk up to one without knowing there's a null in there, you dereference it, you call dot on it, get some member out, and at runtime you get a null reference exception.
Yeah.
And now you have to try to track where did that null come from? Was it supposed to be there? Should I have checked for it? Who's to blame? Right?
Yes.
Much better to have this inside of the type system. So I have an example project here, which I can quickly bring up. Is it okay we go like 2 minutes over?
Sure, we can go over slightly.
Okay. Sorry to whoever's next out there being impatient. So I have the nulls project here with a program that's, let's click the other program away, that seems like perfectly harmless. I'm creating a new person with a first name and a last name. I'm getting the length of their middle name, and I'm printing that length out. And how do you get the length of their middle name? Well, you take the person, you get their middle name, and you get its length, right? No problem. Except if I run this, it's going to crash because the middle name, it turns out, will actually be null when you don't pass in a middle name when you construct them. And so if I go look at the type person, there we go. You can see that I'm actually, can you see that there? Yeah, I'm getting a squiggle on person here. This is, what's happening here is I have a constructor that initializes the first and the last name, but not the middle name.
Yeah, the error there, look at that. Non-nullable property is uninitialized.
Yeah, so what you kind of see and hinted here in these different warning messages is we don't really like you putting nulls into reference types anymore. The string middle name there, it shouldn't really be null. And since we're leaving a null in there, not initializing it, we're telling you that's something wrong. So we're actually this feature is going to be optional because it's going to start warning on your existing code to try to find bugs you have around nullability. Turn this feature on. It says, don't put nulls into reference types anymore. We strongly discourage it. It's a warning. It's not an error. We tell you, hey, if it was up to us, you shouldn't be doing this. So that's what the warning means here. So, but sometimes nulls are nice, right? Sometimes you actually want nulls.
Yeah.
And that's the case for middle name here. So we could say that it's supposed to be null by putting a question mark on it. Now it's a nullable thing. It's fine to leave the null in there, and the warning down here goes away.
Okay.
So now we made it happy over here, but if we go back to the program, you can see that the p.middle name down here now has a squiggle. Are you getting the squiggle?
Hasn't come through yet.
Okay. Well, on my screen, there's a squiggle on p.middle name.
Okay.
Now there's a warning that's saying, hey, you may be dereferencing null here. Possible dereference of a null reference. So now because I put the question mark on, it can now warn over here saying, hey, middle name might be null. You shouldn't dot into it, at least without making sure that there's not a null in here. But if I do the right thing, which I probably should have done all along, I can fix the bug by saying if p.middle name is null, using the pattern version of it, return 0, for instance.
Okay.
Now, the compiler. Oh, now you got the. Now you got
Now I got
the
it. There it
squiggler.
is. Oh, and
Yeah,
it disappeared.
but now it goes away. uh, Now you see that the squiggle went away because it is no longer potentially null. Actually, there's a little bug here. It's going to keep the squiggle on. But so I'm going to do it the old-fashioned way. But if I check for null, the compiler can see me checking for null. Can see I'm not getting down to this line of code if p.middlename was null, and so it's going to take the warning away. And those are the kind of components of this new feature that we call nullable reference types. Either you're not null, or you say you can be null, and then we make you the consumer of that. We make them check for null.
So can I also, instead of writing line 14 with that if statement, can I just use the Elvis operator after the middle name?
Oh yeah, whichever way you like checking for null already, you can use that. So if I use the Elvis operator, say p question dot middle name, sorry, p dot middle name. Let's assume p is not null. P dot middle name question dot length. Then that's absolutely fine. I don't get the warning anymore. Now I get an error though that I'm returning a nullable int instead of an int. But I can use the null coalescing operator to say, well, if the whole thing was null, then return 0.
Very cool.
And now that's another way of fixing it. And again, the warning goes away.
Chop Chopper in the chat room is asking, do you need to enable this behavior? Well, this is a prototype, and you can check it out on the C#Lang GitHub repository if you want to try it out. And there's instructions there for how to experiment with this and give feedback to Mads and the team.
Yeah. This prototype, it's just always on, because you install the prototype, we assume you want to try the feature.
Yeah.
When it comes into C#, because it's going to give new warnings on existing code, that would be like a breaking change to just add. So we put it under a flag where you have to sort of say, I want you to null check my code. Just so that you have your legacy code, it's all well tested. We're not going to start lighting up with 100 warnings unless you ask us to.
Sure. And last question that I want to raise here is, with pattern matching, is null preferred over equals null? And I think you said earlier it's a little bit faster to do that.
Yeah, we actually have a bug in the null prototype where it doesn't discover the is version of it. It doesn't take the warning away. So they clash a little bit. But yes, other than when you're using that prototype, I recommend the is. It's as fast as what you thought you did with the equals, but it's also got to be correct in the cases where equals was overridden and does something that you didn't expect it to when you check for null.
All right. Very cool. Well, I think that's about time now. We've gone over it by just a few minutes.
Yeah, sorry.
No worries. No worries. Thanks so much. This was huge. A lot of the folks in the chat room here are really happy that you were able to answer their questions and show them some of these cool features. So, do you want to share some of this code? We already have the link back to the C#Lang repository, so they can get to the prototype here. But what we saw earlier, where we were working with the tally method, do we want to share that class out?
I can certainly do that, yeah.
Okay. So we'll share that so that folks can take a look and experiment with that a little bit. Thanks so much for joining us. I really appreciated you taking time out of your schedule to help us out here today.
Thanks for having me.
Very cool. All right. So, oh, look at the applause. Look at them applauding there in the chat room. And yeah, you get doodle on the whiteboard. Thanks so much. I'll catch you another time, and I'm going to start getting ready for our next speaker. Alrighty, see you, Matt.
See ya.
All right, there he goes. And we'll go back over to just me for a second here while I get set up for Phil. So that was really cool. I'm thrilled that Mads really took that time. It's hard to get some of these folks who are at the top of their skill set, right? I mean, literally the guy building C#, able to join us and take some time. That was just great that we were able to have him join us.